plan is for next week to, whether we get done with chapter 4 or not, wherever we get by the end of next Monday, we will then test on Tuesday. Okay, so if we have to do 2 sections when we get back over chapter 4, that's fine. But 4.3 talks about triangle congruence, and it's by 2 new techniques. Okay, but based off of what we've already learned with side, 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 and side, angle, side, this is no different. Okay, it's just the different parts. Instead of 2 sides, now we're talking about 2 angles. Instead of the angle being in the middle, now the side is in the middle. Okay, so we have ASA and AAS, okay, as our additional congruence tools. Okay, now angle side angle is a postulate. Angle side angle is a postulate. I don't know if I've got a applet attached here. Yeah, I do. All right, so it says if 2 angles in the included side of one triangle are congruent to 2 angles in the included side of another triangle, then the triangles are congruent. So included again, now it's the side that is between 2 angles. Okay? So you guys agree that if we highlight these 2 angles, I think this is easier to see. If we highlight these 2 angles there and there, that it makes sense that AC is the side that's between them. Okay? AC, another way to think about it is that it's the side that is formed by the overlap of angle A and angle C's sides. They only overlap on AC. But here is a applet to kind of maybe justify this concept. Get rid of some of this. All right, so we start with, basically what I'm going to do is I'm going to tell you I've got 2 angles, angle A and angle B. Okay, and let's say that we cut them out, like we take a protractor and cut those angles out in like cardboard. Okay, and then I've got this angle or this segment between them of 5.74. So I say we take this yardstick and we cut it off at 5.74 whatevers. Okay, and we put the 2 angles at the end of those, or that the end of those, that yardstick. Okay, so we create something like this. Does that make sense? Okay, so we got cardboard cut out of an angle here, cardboard cut out of an angle here, and we've taped that distance of that yardstick right here. Okay. Well, because this is a cardboard cutout, this angle here is defined, and if I follow that edge of that angle and keep going, would you guys agree that there will be a segment that keeps going in this direction? Would you agree that I can keep taking this distance here, this segment, and extending it in that direction? Will they intersect? If I extend them, they intersect there at P. Okay? Now, what happens with these triangles? So, I should be able to move one of these. If I do that, those 2 rotate a little bit. But those 2 triangles, one's rotate a little bit that I can't fix, but those 2 triangles are identical. Okay? One's got 77.83, 43.08, 77.83, 43.08. So that angle up there is going to be the same as that one. If I look at the distances, I never tried to make that distance the same as that distance. And that's not the one I wanted to click on. The distance from Q to P, 4.81, same as that distance there, right? Would you guys agree that this distance B to C, which I never knew what that distance was, 6.88, what do you think R to P is going to be? 6.88. Okay, I never worried about what those were, right? The only thing that I worried about were those dimensions right there, an angle, a side, and an angle, and that then made everything else, forces everything else to be the same as well. Okay, so that's angle, side, angle. Okay, so as we do proofs now, we have at our disposal those three tools: side, 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 angle, side, or angle, side, angle. Okay, those are the things that we can use as we work through proofs, which should be of a benefit. The more ways that we have the ability to show triangles congruent, the easier our proofs should be. Okay, the less steps they should be. So let's talk about this proof here. Our goal is to show that AD is congruent to CD. AD is congruent to CD, provided that we have the given information that BD is perpendicular to AC and that BD bisects angle ADC. Okay. So again, we're trying to prove two segments congruent, but remember, if we got triangles in our picture, the first goal, spell goal right. The first goal is to prove triangles congruent. Okay, so that's what I'm going to start to do first. Because if I can show these two triangles, like triangle 1 and triangle 2, congruent, then that and that will end up being corresponding parts, and I'll have what I need. Okay, so let's go through and talk about our given information here. So it says DB is perpendicular to AC. And they also say that BD bisects angle ADC. Okay. Would you guys consider that symbol a vocabulary word? Okay, if that's a vocabulary word, what does that generate for us? Okay, so it's perpendicular, right? So it's going to be, our reason will be definition of perpendicular lines. But what do perpendicular lines create for us through the definition? Okay, so those are what kind of angles? Right angles. So we know based through that definition that angle there and that angle there are right angles, correct? So I'm going to write that. I'm going to say angle ABD and angle CBD are right angles. Definition of perpendicular lines. Okay, so this is a pattern, and we've seen it a couple times previously. If you have two angles or three angles or four angles that are right angles, what can you say about them compared to one another? And remember what our goal is for trying to show triangles congruent. We're trying to show parts congruent, right? So if I know two angles are right angles, how can I compare them to one another? Not there yet. If you had a 90-degree angle, you had a right angle on your desk. Okay? Let's say Robert had a right angle on his desk. How do you compare them? Say again? How do you compare them? Can I take yours and overlap it on his? And can I take his and overlap it on yours? Will they match up completely? If you take two right angles, are any two right angles ever different? No. So two right angles are always the same, which would be congruence, the word that we use there. So I'm going to say that angle ABD is congruent to angle CBD. And it's because all right angles are congruent. And that's we did a proof of this earlier in the year. All right. So if I have two angles that are right angles, they're both 90 degrees. So they have the same measurement. And if they're both angles, they're the same shape. So the same shape, same size. So that means they're congruent. Okay, so all right angles are congruent. Okay, so that's nice because now in my picture, I can put that little mark in there, right? And that was one of the tasks, is that when we tried to show triangles congruent, we need to somewhere over here have 3 congruencies written. We just came up with 1. We need 2 more. Okay? So usually, at least 2 of those come from the vocabulary. What's bisects mean? Okay, but what does it mean for if this is an angle bisector? So bisect does mean kind of cross or cut, but mathematically it's got an added feature that it does it so that the parts are equal, right? So what do I gain if I say that BD is a bisector? So they're saying BD bisects this angle right here. Can you identify that angle there and that angle there are the same? Does that make sense? So let's label, how should I name those? ADB and CDB. And that's the definition of an angle bisector. So adding that to my picture. Put 2 marks in this, because we obviously know that those are not the same as the right angles, right? So I need to differentiate and put 2 marks in those. Okay. So now we've got some stuff going on here that provides us more information about these triangles, and we've got 2 parts. We've got 2 angles congruent to 2 angles, right? So go through our tools to show triangles congruent so far, and there are these 3 things, right? Okay, which one of those would be the least likely for us to use at this moment? Side, 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 because that would mean that everything we've done so far has been a waste of our time because we won't be able to use any of this stuff. Okay. Now, so side, 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 I'm automatically not going to use it, out the window. Makes these 2 more appropriate, but of those 2, which one is probably most appropriate? Angle, side, angle, because you've already got 2 angles, right? So if I already got 2 angles, now I got to think and this is why we add stuff to our picture. If I'm adding to my picture, can we see that this would be the side that would be stuck between these 2 angles on the left-hand side? Okay. So it allows me not only to determine the parts that I have and the parts that I need, but it also allows me to determine their location. Okay. Can I say anything about DB? Is DB kind of a special segment here? Why? Okay, it's shared. It's in both triangles. So I'm going to say that DB is congruent to DB. Yes. Oh man, what is going on? The reason for DB being congruent to DB is reflexive. And the idea here, if we're not adding stuff to our picture, we are going to have a hard time trying to decipher and determine what is the quickest approach, the quickest route to proving triangles congruent. If we weren't adding stuff to our picture and we just left it blank like that, would you know that you had angle side angle in that order by just looking at what I highlight, by looking at that congruency, because that's one congruency. There's your second one, and there's your third one. By just looking at those without the picture, so you just look solely at that information, would you know the order that they are in? No, that's very hard, right? Okay, so that's why we're always adding to the picture. All right, so we have those congruencies. So now that we have those three congruencies, once you say three congruencies and they match up to a particular order, one of these three orders, you can then automatically say the triangles. I'm going to say triangle ABD is congruent to triangle. If I go ABD, I got to name the other one CBD, right? And they're going to be congruent. What was the order? Angle, side, angle, right? Okay. So whenever you name triangles congruent, it's always going to be because of that order, whether it be side, 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 angle, side, or angle, side, angle, or here and eventually angle, angle, side. Yes. Yep, you're always going to have to find these three. And like I said, and in this one here, these two were hidden in vocabulary words, right? So they're going to do that. They're always going to hide in some fashion two of them, whether it be through vocabulary words or other theorems. They will implicitly give you two of them. You will then usually have to either look at your picture. So right now, find this third one is always found by looking at overlapping segments so far, okay? But sometimes there might be a kind of a segment addition process that we go through or an angle addition process that we go through that will allow that third congruency to kind of formulate, okay? But the first two usually going to be produced or provided using vocabulary words. So now that we have that, now that we know that those two triangles are congruent, what can you say about AD, which would be the first letter here and the last letter, compared to CD, the first letter and the last letter? They're congruent. So you can say step 7, AD is congruent to CD. And our reason for that is CPCTC. You guys remember what that CPCTC stands for? Care Bear? So that I gave that question on the quiz on Friday, right? Because those C's represent different words. So the first C stands for corresponding. Okay? Corresponding parts. So essentially saying matching parts. Okay? Of congruent triangles. So meaning that these corresponding parts are coming from congruent triangles. We have congruent triangles, right? Okay? So corresponding parts like AD and DC, they are matching. They are corresponding. They're coming from two triangles that are congruent. And if that's the case, then those two parts themselves are congruent. Okay? So CPCTC stands for corresponding parts of congruent triangles are congruent. Okay? Okay, so this theorem here, this is actually a theorem. So everything we've done so far has been a postulate where we can't prove it. This we can actually prove. Okay? Theorems are the ones you can't prove. Postulates you cannot. So side, side, side is a postulate. So side, 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 angle, side, angle. Those are all postulates. Those are things that we cannot prove. This one we can't. Okay? And it's going to be, I think, obvious on eventually why we can prove this. Okay? But it says if two angles in a non-included side. Two angles in a non-included side. So that's why the S is at the end of the name here, is to show that it is not between the two angles that we have identified. Okay? So all the other ones that we've done are palindromes. You guys know what a palindrome is? Mom, dad, race car. Those are all palindromes. What is mom, dad, race car? You can spell them forwards and backwards, and it's still the same word. Okay. So angle, side is not one, right? Okay. So when I go side, 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 I can reverse that and go side, side, side. When I go side, angle, side, I reverse it. It's side, angle, side, right? So angle, side is the theorem, but you can have S side, angle, still the same thing, right? Okay. So I don't know how many textbooks. I've never seen a textbook write S side, angle. So there's nothing wrong with it. Okay. But it just tells me that the side is not between the two angles. Okay. And now the reason this is a theorem is because of what we know about triangles. How many degrees are there in a triangle? 180. So let's say in this picture here that angle A, give me a number for angle A. 72. So if angle A is 72, what's angle B? 72. Okay, give me an angle for B. Let's make it easier. Let's go 28. Okay, so if I do that, how many degrees have I used so far? I've used 100 degrees. How much is left for angle C then? 80. How much is left for angle F? 80. What would you tell me about angle C and angle F? They're congruent. That's the third angle theorem. Remember hearing that phrase before? If two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. Okay, so we know angle C and angle F have to be congruent. Well, if I look at angle C and angle F and I ignore, let's say, that right there, they are congruent. That angle and this angle here that I'm deleting are congruent. But if I do that, what orientation of parts do you have right there? You have angle, side, angle. Does that make sense? So angle, side is a theorem because the third angles theorem, if I have angle, side, the third angles theorem tells me that the third angles are congruent. And when the third angles are congruent, it presents us the ability to show the triangle is congruent by angle, side, angle. Therefore, when I start with information like this all the time, that will always be the case. So no matter when you have angle, side, you automatically, by default, eventually get angle, side, angle. So that's why this is a theorem. Does that make sense? Okay. Now, if we think about, just to help you remember these orientations, we have side, side, side. We have side, side, angle, side, angle, and angle, side, right? And as I said before, this could be side, angle, okay? You can do these in any order, okay, forwards and backwards. Obviously, this still gives me side, 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 either direction. Side, angle, side, either direction. What is one orientation that we have not used? Side, side, angle. That is the one that we have not used. And you will never use it. Well, think about this. If this was a palindrome, if I was able to write that one side, angle, how can I write that one? That's a problem, right? Okay. Now, it's not a problem because it's a bad word. It's a problem because when I give you two sides and an angle, you are not guaranteed that the other parts are going to be congruent. Okay. So let me see here. All right, so those, we'll talk about that later. So those four things are your tools to show triangles congruent. Okay. Just non-included sides, real quick. I think it maybe makes use to talk about this real quick. Which side up there could you classify as non-included between those two angles? That's an angle. RT, so RT would be an angle that is not between side that is not between these two angles, right? Is there another one? RS, okay? So those would be your two non-included sides. So that's kind of the structure that we're looking for when we're going to use angle, side, okay? Skip that. So in your homework, they're going to ask you questions like this. They're going to say, state if two triangles are congruent. If they are, state how you know. So how you know would be that they're side, 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 angle, side, side, angle, or angle, side. So, say it again? Well, what would be the third side that you know, or the second side that you know here? Okay, so this one here, congruent to itself? So what is the order of parts? Is the angle, so when I go, you know you're going to have two sides, right? Is the angle in the middle of those two sides? Or is this angle, so it's side, side, angle, is that one of our postulates or theorems? No. So this one, so we've got our tools. We got angle, side, angle. Oh. So we got angle, side, angle. We got side, 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 angle, side, and angle, angle, side. The information provided so far in this picture does not align with any of these. Okay, the one that it does align with is one that we said doesn't guarantee congruency. There are some structures, depending on the values that I give you for the sides and the angle and side-side angle, there could be congruency, but it's not guaranteed. Does that make sense? The other four, angle, side, 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 angle, side, and angle, angle, side, those guarantee congruence. Okay, so this does not, side, angle does not guarantee it. It could happen, but they're not guaranteed. Angle, angle, side. How are you going angle, angle, side? Okay, so you're saying that this angle here is congruent to that angle there. How would you know that, though? Okay, so you know these two lines are going to be parallel because that angle and that angle are alternate interior, and they're congruent. You got parallel lines. But does that guarantee that these are going to be? So that makes this, so what we're saying, even though it looks like it, that would make this bare minimum that kind of shape, which that would be a trapezoid. We're saying triangle 1, triangle 2 would not necessarily be congruent. Does that make sense? The only way that I could tell that these two angles here, there and there are congruent is if they had markings that those were parallel. Okay. So these being parallel does not dictate those two. What about this? Isn't that a right angle? Okay, so it looks like it, but we don't know, right? It could be 89 degrees. What if I did put an angle right there, right angle and a right angle there? Okay, which is that one there, right? Okay, so that would work. But initially, just off the information, without adding any new information, can I say that they are congruent? No. So does that make them incongruent? Okay, good. Okay, so when I say that you're not an A student, it doesn't mean the complete opposite, that you're an F student, right? So when I say it's not congruent, or I don't know them to be congruent, it does not mean that they are incongruent. It just means I don't know enough to say either way. Okay. What about these two? Are you sure? Okay, so you got that angle congruent to that angle, right? You've got that angle congruent to that angle, right? Yep. And then you've got this middle side that is between and shared by both, right? So you do have angle, side, angle there. What about this one? So this side is shared, so it's side, side, side. Or that one. Why is it angle, side, angle? Okay, so I've got a vertical angle there and there, correct? So we got angle, side, angle. Okay. Here's a question. If we're doing this in a proof and somebody recognizes that they got those vertical angles right there, could somebody also then maybe say that these angles are congruent? Okay. So let's say student one proves this using angle, side, angle. And that would be the most efficient, quickest way to do it. But student 2 says, I'm going to use third angle theorem and then show if I use third angle theorem, would you have, using the information I've highlighted now, would it be okay that to say that these are congruent by angle, angle, side? Huh? So angle, side, is not real. So angle, angle, side is legit, right? So you could be doing it one way using angle, side, angle. Your neighbor could do it using angle, angle, side, and both of you be right. One might be a little bit longer than the others, but your logic is still going to conclude congruency in the triangles, and that's our goal. Okay. What about these two? Not enough information. Okay, nothing overlapping, nothing being shared, no additional like vocabulary or anything that provides maybe congruencies. No distance is known. So you got two congruencies, but you don't know a third, so no conclusion. Okay. What about these two? Angle, side angle. Because you've got vertical angles here, right? Okay, so that's really the same one as that one was. What about that one? Good. So you got side angle, side here. That's the orientation. And you do have congruency of the same parts over here, but they're in the order of angle. We'll go side, side angle. Okay. And what we have to realize is that when we have our postulates, it says that you have a side, two sides, and an included angle of one triangle congruent to two sides and the included angle of a second triangle. We don't have that statement or that clause here. We don't have an included angle being congruent in that second triangle to the one that's in the first triangle. So what I'm trying to get at here with this example is you can't just look at one triangle and say, oh, that triangle has the orientation or part, side angle, side, so it's got to be congruent to this one too. Okay? They both have to demonstrate the same order of parts to guarantee congruency. These triangles might be 100% congruent, but the information provided, we don't know that. Okay? What about those two? Side, side, side. What about those two? Side, angle, side. You get the vertical angles again. What if I did this? What if I said, what if I gave you this picture? And I said, based off this information, that angle congruent to that angle congruent to that one, and that one congruent to that one. Angle, 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 huh? Is that one of our theorems or postulates? No, it's not. Does anybody know whether they would be congruent or not? All right, so that was weird. All right. So this is the setup that I showed you with angle, side angle previously. And with angle, side angle, AB, that distance was the same thing as C to D, right? I'm going to change them. I'm going to make sure that they're different. Okay, so those are not the same. Okay, but if I've got an angle of 40, an angle of 60, an angle of 40, an angle of 60, what is this third angle up here, E, and this third angle, F, going to be? They're both going to be 80. Okay, so when I make those, does it guarantee? So I've got angle, 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 right? But do we see that distance right there is different than that one? So these two triangles, I don't know if I can put them on top of one another. Okay, those two triangles are obviously, they've got angle, 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 but they're not the same, right? But do you see that when I take that angle or that segment divided by that one, I get 0.46? Take that one divided by that one, I get 0.46. Does anybody know what I'll get if I take AB divided by CD? 0.46. Okay. Does anybody know what these two triangles are called? Not equilateral. Equilateral means all the distances are going to be the same. In comparison to one, they're not congruent. They're incongruent. But because these ratios are the same, no, starts with S. Do anybody have brothers and sisters? Do you have are you the exact same as your brother or sister? So you're not congruent to your brother or sister, but you are similar. Okay, so these triangles are referred to as similar. Okay, so angle, angle, angle does not guarantee congruence; it guarantees similarity. Okay, and to be honest, so that number 0.46 is what we call a scale factor that allows us to take one of those triangles and multiply every part of it, every distance of it, and get the other one. Does that make sense? Okay, so I take that bigger one, multiply by 0.46, it will shrink that down to the smaller triangle. Okay? Congruency is actually a special case scenario of similarity. Congruency is when the scale factor is 1. I multiply a number by 1, what do I get? No. I get itself. I get the number I started with, right? Okay? So angle, angle, angle does not guarantee congruency. They could be congruent, but the most information we know, the bare minimum information we know is that they'd be similar. Okay? These other questions, I'm going to skip them for now with you. I think you got a good hang of these. The rest of them are, if I have angle, side, angle, and that's the task that I'm set to show things congruent, what missing information up there needs to be filled in. Okay? So if I'm going to go angle, side, angle, what angle do you need? Do you guys agree you need that angle there, congruent to that angle there? Because there's this side here, UT, there's no marking it, but UT is the S that's in the middle, right? Because it's being shared. Okay? So I'm going to open up 4.3. That'll be due Wednesday. Does this stuff make sense, though? Feel comfortable with this?